Have you ever looked closely at a world map? Well, if you have, you might have noticed something quite peculiar. The eastern coastline of South America seems to nestle perfectly into the western coastline of Africa. They look like two giant puzzle pieces that were once connected but have since drifted apart. This simple observation, a curious thought that many might have dismissed, was the seed of a revolutionary idea. It was a visual whisper from the Earth's deep past, a hint that the solid ground beneath our feet was not always as it is today. This single, powerful image sparked the imagination of a man who would challenge the very foundations of geology. That man was Alfred Wegener. Born in Germany in 1880, Wegener was not a geologist by trade. His primary fields were meteorology and geophysics. In the year 1912, Wegener stood before the scientific community and proposed a bold and, to many, an outrageous concept. He declared that all the continents we see today were once joined together in a single, colossal landmass. He gave this groundbreaking idea a name: Continental Drift. Wegener's idea suggested a world in constant, slow-motion transformation. When a supercontinent, which he later called Pangea, dominated the globe, this massive continent began to fracture. The pieces, our modern continents, started to slowly float away from each other, plowing through the ocean basins over immense geological timescales. Alfred Wegener did not base his radical theory on a single observation. Instead, he meticulously gathered evidence from various scientific disciplines. The most intuitive piece of evidence was the remarkable jigsaw puzzle fit of the continents, beyond South America and Africa to North America, Greenland, and Europe. Next, he turned to the fossil record: Mesosaurus in Brazil and South Africa, and nowhere else. Glossopteris spread across continents now separated by oceans. Mountain chains aligned across the Atlantic, one torn belt carried apart. Paleoclimatology showed glaciers in tropics and coal in cold lands, evidence that continents moved. Despite the weight of his assembled evidence, his theory of continental drift was met with fierce and widespread opposition. In 1915, he published The Origin of Continents and Oceans. A few scientists were intrigued, but the vast majority of geologists reacted with scorn and derision. They were deeply invested in a prevailing idea: a static Earth, fixed continents, sinking land bridges, used to explain fossil distributions. Wegener's proposal threatened their life's work. The single greatest weakness critics attacked: no plausible mechanism. He could show continents had likely moved, but he could not explain how. Centrifugal force from Earth's rotation, tidal forces from the sun and the moon. Physicists calculated these forces were far too weak to overcome the immense friction of continents plowing through the ocean floor. Criticism turned personal. He was mocked as an amateur meteorologist, accused of cherry-picking. Through it all, he revised his book, gathered new evidence, and kept debating. Alfred Wegener was more than just a theoretical scientist. He was a man of action. A pioneering meteorologist and glaciologist, he chased data across Greenland's ice cap. He balanced field risk with rigorous measurement: ice motion and thickness, Arctic weather. In 1930, he set out to establish 3 interior stations for a year of observations. A late start and brutal storms delayed vital supplies to the central station, IJsselmeer. Fearing for the men there, Wegener and Willemsen led a desperate resupply dash. They reached IJsselmeer in late October, spent a brief rest, and on his 50th birthday, Wegener and Willemsen set off for the coast. It was the last time they were seen alive. Alfred Wegener's body was found the following spring, carefully buried by Willemsen, who was lost to the ice. He died pursuing science and exploration, his theories still dismissed. After World War II, new tools mapped the seafloor in unprecedented detail. Scientists discovered mid-ocean ridges and crust that grows younger toward them. Hess and Dietz proposed seafloor spreading, the missing mechanism. Continents don't plow the seafloor. Plates carry them. Plate tectonics was born. It explained quakes, volcanoes, and mountain ranges. Today, Wegener is hailed as a visionary. His persistence changed how we see our restless planet.